Now on R1, as we spoke, we will leave OSPF, but I just want to check whether OSPF is still there. I do see there's a neighborship, so OSPF is good. Show IP OSPF neighbor. Done. Now let me go to router 2 and remove whatever that is running there and put ISIS. I see here OSPF is running. Show run section router OSPF. I see OSPF, so I remove that now. Gone. Likewise, I have to remove OSPF on router 6 towards that VRF Tinko. So on R6, show run section router OSPF. So here it won't come. Run command will not work on user mode. You need to go to privilege mode.
And where we will use BGP then?
BGP we are not using anywhere. BGP is only in the service provider, the core, the VPN provider.
Okay.
VPN is only in the middle.
Between the PE and the CE devices, I mean, we usually don't configure IGP protocols, right, Jay?
No, see, listen carefully. Whenever you don't have dual homing or multi-homing, you will have either default route or a routing protocol.
BGP.
What? Repeating again. Whenever you have multi-homing, you will have BGP. Whenever you have dual homing or multi-homing, you will have BGP. Tell me, is there a dual home or multi-home between R1 and R3?
No.
Then why you need BGP?
No. So in those cases, a static route will do.
Static
So
route
my
also
question
good,
is,
but if you want to advertise, listen carefully. This is VPN technology. You are not talking to internet. When you are talking to internet, you don't know what destination you are talking. You simply have a default route. But this is a VPN, WAN technology, which connects to your remote office. And you know what networks are there in your remote office, and you know what networks are there in your local office. Now you can use either a routing protocol or a static route to reach those networks.
okay.
Your wish, again, static route is also okay. Because you know it is your remote office. You know what all network involved there. You can do this. So.
Yeah. But Jay, what do you mean by multi-homing?
Connecting to more than one ISP is multi-homing. Connecting to more than one ISP. Here we have only one ISP. R3 has got how many ISPs? Sorry, R1. R1 has got how many ISPs? Only one.
ISP.
Autonomous System 10, BGP AS10, which is router 3. Here every customer has got only one ISP, only one connection, only one WAN connection. Just only one. All right, here we go. So,
Can we have, Jay, after this, can we have the one session with dual homing and multi-homing? Can we try that?
Then you no need OSPF. You already have those videos. We did BGP in all the sites. You will have BGP. That's all. You will have BGP.
Oh.
If
Okay.
you have multi-homing, you will have BGP, and you remember whatever you learn in BGP class. You tune the
Yeah.
attribute
Yeah.
and send. That is the what is the difference? Here you have an MPLS network. There in
Yeah. Yeah.
our class we did not have MPLS.
Okay. So the design will be like to R3, one more router will be connected. Uh, yeah. And between R1 and R2, we will have one connectivity. Correct?
Hmm. One minute. We have a question from one of our student.
Okay.
Let me also call him in the call. Here, Vijay. Good morning. விஜய் நான் பிஜிபி கிளாஸ் எம்பிஎல்எஸ் கிளாஸ்ல இருக்கிறேன். உங்களுக்கு விருப்பமா இருந்தா நீங்க பிஜிபி கிளாஸ் பிஜிபி உங்களுடைய கொஸ்டின்ஸை நீங்க வந்து சொல்லலாம். உங்களை எப்படி இன்வைட் பண்ணட்டுமா, வர முடியுமா ஆன்லைனு?
சார் இப்போ ஆபீஸ்ல இருக்கேன் சார்.
சரி, பரவாயில்ல. என்ன உங்க கொஸ்டின் சொல்லுங்க.
இல்ல சார், ஸ்டேட் மெஷின் ஃப்ளோ இருக்குல்ல சார், அதுல சில டவுட் இருக்கு. அந்த ஆக்டிவ் ஸ்டாண்ட் பை இருக்கு இல்லையா, எஸ்டாப்ளிஷ்டு பிஜிபி ஸ்டேட் மெஷின் சார்.
பாருங்க, ஃபர்ஸ்ட் த்ரீ வே ஹேண்ட்ஷேக் நடக்கும்.
ஓகே ஓகே.
த்ரீ வே ஹேண்ட்ஷேக் சக்சஸ்ஃபுல்லா எப்போ நடக்கும்னா, okay, let me put it in English. Sai and the co is also in listening to this conversation, who are in MPLS class. Okay. So let me put it in English. You see, when will two BGP form peering? When the neighbor addresses are properly configured with autonomous system numbers.
Yes, sir.
When the BGP source matches with the neighbor statement in the neighbor router, then three-way handshake will be successful. Repeating again. When there is reachability between the neighbor address and also the neighbor address is the source of the incoming packet, then three-way handshake will happen. After three-way handshake, after three-way handshake, open message will be sent. Now, the receiving router, when it receives the open message, in that open message, it will see the router ID of the peer. It will also see the neighbor address. It will also see the autonomous system number. When all this matches with the local configuration, it says open confirm. So open confirm message will be sent. So this happens on both sides. Both sides they send open message. Both sides they receive the confirm message. And then the keep alive messages will be repeatedly going every now and then to make sure that they are still connected. And then update message will be sent with all the routes they have along with the attribute. Update message. Once the update message is shared between them, they get acknowledgement for saying that I received your update. Once that is also over, they reach the established state. That's all. They reach established state. They are neighbor now.
Okay, sir.
Any other question? See, when BGP neighborship is struck in active, what are all the chances? First of all, we need to know what is active state. Whenever a router tries to reach the neighbor address, see, in one of the router you configured neighbor as 2.2.2.2. So this router now tries to reach 2.2.2.2. By using the route in the routing table, it tries to reach 2.2.2.2. But for some reason, the 2.2.2.2 is not available there. So it will be keep on trying. That is what active state. What is idle state? That is one step before active state. Before active state, the router will look into the routing table to see whether I have a route to that 2.2.2.2. That state, where it is trying to pick a route, find a route, is idle state. Once the route is found, this router will move to active state, trying to use the route and send the negotiation packet. But unfortunately, the 2.2.2.2 is not available. Route is available, but the destination is unreachable. Destination is off, maybe turned off. Or destination, instead of 2.2.2.2, someone have changed the IP address now to 2.2.2.3. Someone has changed the IP address. For some reason, the 2222 is not responding even though there is a route. Then it will continue to be in an active state. So if you will fix this routing issue, it will move to next state, which is open send, open confirm, update, acknowledgement, and established. Any other question?
Sir, when there is a VRF comes, no, sir?
Yes.
How it will be the same flow?
Same procedure. When we have VRF, it will use the VRF routing table to send all the traffic out. Earlier, when we don't have VRF routing table, there is only default routing table. So packet was sourced from the default routing table. Now it is sourced from another routing table, which is VRF routing table. That's all the differences. There is no much difference. Whenever you have VRF, the routing table has got that interface only on the VRF table. The VRF routing table only have the interface connecting the neighbor in VRF routing table. So it will source all the BGP packet. That is why we go under address family VPN v4 VRF and activate the neighbor. When you enable BGP, you go to address family IPv4 VRF customer A, and then you will go inside and say neighbor, so that neighbor negotiation will start from VRF table, not from the default routing table.
Okay.
So if VRF routing table have route, if VRF routing table have route, it will move from idle state to active state. If VRF routing table don't have route for neighbor to reach neighbor, then it will be in idle state. When there is a route, if the neighbor is not properly configured with the right IP address, then it will be in active state. Always in active state. No, you asked me some question. No, sorry, I came in the middle. Tell me, please. A question.
So the interface check and all, it will be completed in the initial stage itself, right? So
yeah,
interface check starts.
Those things are very basic routing steps.
Basic.
After that, only the three-way handshake starts.
Three-way handshake starts. Okay. First interface check, then three-way handshake. Okay.
Yes.
TCP connection will be established. Then after that, only ideal connector.
Yes. Yes.
Sir, this active means it will check only for the neighbor. It will look for a neighbor.
Reachability. There is a route. Reachability is there for the network, but not to the host address. It is trying to reach that host address. You have the route to reach the network, but that particular IP address still not responded. Then it is active state.
Okay. So this the keep alive messages, what time it will send, sir?
Every 60 seconds.
All the BGP establishment, or when it will be sent, sir?
No, not after establishment. After establishment, it is sent every 60 seconds. Before establishment, it is sent immediately after three-way handshake.
Oh, immediately after three-way handshake. Okay.
Immediately, no. Immediately after three-way handshake, open message. Immediately after open message, keep alive will go. Right? Any other question?
Okay, sir. Okay, sir. Yeah, that's
all right. Then I'm back to class. Thank you. Bye.
Thank you, sir. Thank you, sir.
So was it useful? Go. Sai.
Yes.
So the discussion was useful for you? All right.
Yes.
Okay. Right. Now where we are. Go, please. Can you help me? Where were we? What was the discussion we were in?
Yeah, so it's on multi-homing or say first if it's possible to.
See, if it is multi-homing, what you will be having? Let me draw and explain you. So those things you need to try from your side, and when you face difficulty, you can ask me. But I'm just giving you an idea. So if it is multi-homing, you will have another connection. Like this, you will have another ISP here connecting to this remote site. So you have an option now, either to go via this MPLS tunnel or this MPLS tunnel, or you may be having MPLS here. Here you may be having normal IP routing using the internet. So now you may use MPLS as the primary path by setting some local preference on R1, and then IP route as the secondary path in case if MPLS goes down. Sai, are you there? Like R3, R4, R5, and R6, you will have some other RA, RB, RC, and RD. This is another ISP, maybe Autonomous System 100, 1000. And R1 has got connection to A, R2 has got connection to D. So now R1 has got multi-homing. R1 can reach R2 this way or this way. In that case, BGP is mandatory, so that you can have policies. You can set weight or local preference or something and have policy in path selection.
Okay, Jay, how about if we have two customer edge routers and two service providers?
Two customer edge router, okay. If you have two customer edge routers, then you need to take two connections. Like this.
Yeah, R1 is accompanied by another router.
Yeah, here.
And
R11.
yeah,
Okay.
correct.
You will have an IBGP
You mean
here.
You mean in case of router 7 also?
Yeah, that's what I'm saying. You will have like this, and then one connection here, one connection here. And in between these two, you will have IBGP.
Jay, one question. So we will have one interface configured with, two interfaces configured with two IP addresses, right? On R1 and R11 between these devices.
Yeah.
So how do we write the routing part? We need to do the redistribution, right?
Why? No.
Sorry, we are doing, if it is BGP, we don't have to.
Yeah.
Understood that.
In this scenario, you will have only BGP. You should not have OSPF or EAGRP or anything.
Yeah, got it.
So you will see people having only BGP in this type of scenario.
No,
you mean that
I really want to see. Sorry, Ko. 1 second, Ko. Very sorry.
Yes, yeah, no problem.
I really want to see how do we do the configurations there.
Okay, we'll
in this
do a
kind of
lab. Okay,
scenarios. Yeah.
you also
Yeah.
because you asked me the topology I have given you. You also try if you want to try now. But later, once this MPLS VPN topic is over, remind me.
Yeah. Okay.
We'll have one topology like that. It'll go at least for 3 days. 3 days class.
Okay. Okay.
We'll do that. What you asked is seen in various places, maybe in your office also.
Yeah. Yeah. We have similar kind of setup. So I'd like to show the configuration once because I don't see in the BGP. I see similar configuration between R1 and R2. I don't see any other you know using attributes or selecting the interested traffic and put it in an ACL. I don't see this configuration actually, or I don't know if I'm missing something. I'd like to show, actually the reason I wanted to come to you when I was in Bangalore is to show the configuration actually.
Yeah, I remember. Don't clean it properly, then that will conflict with the other configurations. Sure, and section.
Jay, but why we remove BGP actually?
Because we don't want BGP, we want to have RIP here. We don't want this BGP neighborship. We want to have RIP relationship with that R7. Go, you need to respond.
No, I mean in case. Yeah, but I mean in case that we will use multi-protocol. Multiple protocol is we don't need BGP, right?
What multiple
On all
protocol?
routers.
I don't understand what you're talking about.
No, because you said we will use RIP and
Correct. Correct.
RIP.
Listen, I said we will use RIP here. Correct. So earlier what was running? BGP. I removed it. Now I'm removing from here BGP that is running towards this R7. I'm not running BGP here. BGP is still running here. I'm just running BGP relationship which was there earlier because I want to replace it with RIP. Please respond. Please respond.
We're trying with
That's my
IGP
question.
scope.
Yeah, but that's my question. I thought that he will remove BGP completely on all routers.
No. In the service provider, we need, right? We need the
Yes.
BGP for the VPN. Only on the customer devices, we are removing BGP and we are trying with ISAS, EIGRP, OSPF and RIP.
Please respond, Go. He's telling you.
Did you get it? Go.
Yes, I get it.
You got the point? Yeah, okay. Wonderful.
Yeah.
No. So I removed BGP which was running towards R7 now, and that you can see on R3. I have removed R7 neighborship. I'm not removing BGP from R3. Only the BGP that was running towards the customer I'm removing. Now, likewise on R8, if I am having BGP, I should remove it because we are planning to put, see, we have BGP. Show IP protocol, we have BGP. I'm going to remove this and we will be putting EIGRP. No router BGP 800. And we are going to put EIGRP. Router 6. Router 6 also I have to remove. Tell me, where should I remove the neighborship that I configured towards R8? Where will I find it? Where should I remove? I want to remove BGP that I configured on R6 to form neighbor with R8. Where should I remove? Where will it be seen?
On the IPv4 VRF address family VRF.
Correct. These things were taught after you joined course, so you should be knowing this thing. Don't think that this is something BGP related. No, we saw these things after you joined. Show run section router BGP, and you see here it is. This Binku. If I say Tinku and Binku, Ko will remember. Yeah, we learned this. Just that day he was laughing when I said this name. Binku and Tinku are very close friends. Okay, remote. Now, we already have OSPF. So on R3, you should be learning route. On R3, when I type show IP VRF, this is the VRF name. I want to check with Tinku on the left. So I say show IP route VRF. I do have route from R1, but I don't have route from R2. The reason is the protocol on R2 is different. We are going to have ISIs. But how many of you know ISIs? None of you. So we should have had some other protocol. I should have done ISIs after teaching, but you asked me, so I'm doing it. Router.
No, but it's a simple configuration, right, Jay? So that's why.
It's not going to be simple because in R6 it should be under VRF ISIs. It's okay. Let's do.
Okay, okay.
Net ID is 49.0000. 00200 is the area. Dot 0000 dot. Okay, and then I need to go under the interface of G. First, let us put Lubeck. IP router ISIS done. Interface G3/0. IP router ISIS done. Now I will check whether this is running show CLNS. Brief. Show IP ISIS.
I thought the configuration will be similar to OSPF. I didn't know all this.
No, not like this. Show protocol. We can see here we got ISIS and ISIS. What am I? I've enabled the ISIS so it will show CLNS routing. ISIS uses CLNS as an algorithm and it is running on G3/0, which is this one. Other things are administratively down, you see, and then it is running on the loopback interface. See, it says CLNS, connectionless network service enabled, which is ISIS. Next, we need to go to the R6. On R6, router ISIS VRF, router ISIS. No. Let's go straight to the interface then. Interface G3/0. IP router ISIS. Show run section router. I can see that ISIS for VRF Tinku is enabled. Now on this, I need to say net ID. Here I need to say net 49 0 200 is the area which I gave there. Okay, now we will see ISIS neighbor coming up. Show ISIS neighbor. You look at this with R6, you have already found neighbor. If that is the case, I should see in R6 show IP route VRF Tinku right. Look at this amazingly, very superbly, you got ISIS route. You have learned ISIS route from the customer. You also learned from the remote customer via BGP. Yeah. Now, if you go to the customer R2 and try pinging 1.1.1.1 with a source of, you will be able to ping. No. No, you will not ping because unless you redistribute into VPN, you will not be able to ping. The reason is R1 do not know to do. You see, show IP route. R1 do not know anything from router 2. So go to R6 and say router BGP 10 IPVRF, address family IPv4 VRF, and then the VRF name is Tinkerite. Redistribute ISIS, and I want both level 1 and level 2, which is default. I don't want to say anything for this. Boom, enough. Likewise, we also need to do another redistribution. Router ISIS VRF, what's the name? Tinku on the right, no? Tinku on the right. Redistribute BGP 10. Metric is optional, I'm saying 10. Now I would like to see the route on router 2. Show IP route. You can see that I have learned from the remote office. Now I can ping the remote office from the local office. If it didn't ping, then I need to check with R1. Did R1 learn the route? R1 has not yet learned the route. So there is something problem with the redistribution from BGP to ISIS and ISIS to BGP. BGP to ISIS is neat because I'm seeing the route here. I'm seeing the route. From BGP tunnel, I have received the route, no problem. But I'm not seeing the route from right customer on the right hand side customer to the left hand side. So the problem is the redistribution on BGP in R6. Show run section router BGP. So I need to say redistribute. It is redistributing only level 2. That's the problem. So by default, it is redistributing only level 2. This is ISIS related. Don't worry. When you learn it, you will learn these things in detail when we are in ISIS class. Now I need to say no, not only level 2. I want even level 1. Redistribute ISIS both level 1-2. Now the verification. Yes. Now it is advertising both 1 and 2. I must be seeing it now on R1. R1, you got the magic. You see, you received the route. Now when I try pinging from R2, this ping will go now. So this is how you need to configure ISIS. See? It is not easy. Even RIP and EIGRP, you think it is easy. No, when it comes to VRF, there is some consideration. That is why we make it as a separate lab. The reason why I asked you to finish OSPF in previous classes, so that you will focus on this. This is something unique. You need to learn a lot. All right, we have finished between the two customers. If you
tomorrow.